Alright guys, here we go. So this is example number 10. This is obviously a good candidate for Kirchhoff's laws. You got 4 cells or batteries there, 4 providers of EMF, and then you've got almost 10 resistors there. 1, 2, 3, 4, 5, 6, 7, 8 resistors there. So that's a pretty good clue that this is a little bit more complex. It's not a simple series or parallel situation. Really, anytime you got the extra EMF there, the extra cells or batteries, it's worth taking the time to do Kirchhoff's laws, as we saw in the example in class. So with this one, let's go ahead and work through it. Remember, the first thing that we need to do is we need to identify direction of current. And again, it doesn't matter if you're right or wrong. We just need to identify a direction for each branch where the current can flow. I'm looking right here at the largest 2 EMFs, the 36 and the 48. So I feel like the current should be going away from both of those positives, which means on this one right here, this middle branch, it's probably going that direction to the right. So I'm going to call that current 1. Down here, I feel like it should be going in this way. Again, from the positive, it flows in that direction. So that means that's going to be my current 2. Current 2 is going to be all of this, right? So I'm going to just make it clear that all of that is current 2, that it's kind of going in a counterclockwise direction. Now for that last one, if I look at the 2 that I already have, it would make sense that if these 2 guys are both coming in, chances are this one would be coming out like this. So I'm going to call that current 3. And so current 3 is going to go that direction, just like that. All right, and so you've got current 1, current 2, current 3. And we've split it up. Remember, each place where there's no division, where it doesn't split into pieces, should all be the same current. So we've got that set up. The next thing is to actually use Kirchhoff's laws. The first of Kirchhoff's laws is that the current into a junction has to be equal to the current out of a junction. So we're going to choose a junction. I'm just going to choose this one right here. You could choose, the only other one that you could choose is over there. It doesn't really matter. You're going to get the same thing either way. But when I choose that junction, I see I1 coming in, and I see I2 coming in, and so that has to be equal to I3 going out. Right? You could also write I1 plus I2 minus I3 equals 0, right? The sum of the current into a location should be equal to 0. That way you don't have any charge buildup, right? Conservation of charge. That's a big idea that AP likes to look at. So there you go. So you got your first equation there. I1 plus I2 equals I3. That's at this junction right here. Current 1 coming in, current 2 coming in, and current 3 going out. Now we just need to pick a couple of loops, right? We've got 3 variables. We're going to need 3 equations. I don't want to use this junction just because it's going to be the same thing, right? It's I3 coming in here and I1 and I2 coming out, so it's going to give me exactly the same formula. Sometimes if there's more junctions, you can actually use more of these, the first law, but in this case, that's not an option. So let's choose a couple more loops. I'm going to choose the one around the outside just because it seems like the outside would be a good choice. It's easy to follow around. So I'm going to start actually right here at G, right before I go through that first one. And I'm going to go counterclockwise around. All right? So I go first through that battery right there, which is 36 volts. I am going from negative to positive. Oh, I don't need to write the volts on there. We know that's what's happening. So I'm going to add up each of the potentials. Then I'm going to go through this resistor, the small R4. That one, of course, the current is current 2 here. And I'm going the correct direction because I said the current was going upwards there. So I'm going the correct direction through. So I expect to lose current as I go through that resistor. So minus 0.2 I2, and then as I continue to go up this way, I'm going to go through the big R5, which was 20 ohms. Now that current is current 3, and it is in the direction of the current there, so I'm going to go minus 20 I3, and then I'm going to continue going around, and I'm going to go through R1. Again, I'm going in the correct direction of the current, so this is going to be minus 0.10, again, still I3. Now I'm going to go through this battery. Notice I'm going from the positive side to the negative side, and so that should be minus 24. And then I continue around. I'm going to go through this one right here. Still current 3, so that's going to be minus another 5 I3. And continuing down through this guy right here, that is now into current 2, right? This bottom piece is current 2. So I've got a minus 78 current 2. I'm going again, this is the positive side, this is the negative side, so that's going to be minus 6 again. And then I'm going to go through this last resistor right here, which is minus 0.05, again, current 2. Now that will take me back to the G point where I started, and so all of that together should be 0. All right, now you should be able to add all of that up and put it together. I am going to take just a second to put that together in a single simple equation. So you can see right here what I did is I just combined all the like terms, I put all the constants together, I put all the I2s together, and I put all the I3s together. I'll do a little bit more rearranging later, but that's enough for now. Now I do need one more loop because I do still have 2 equations with 3 unknowns, and so I do need to choose another loop somewhere. It doesn't really matter where. I'm going to go ahead and choose this bottom loop just because I think it'll be fun. So I'm gonna start here at point J, and I'm just gonna kind of go in this direction. Again, I'll go counterclockwise around that loop. All right, and so that was totally random. Well, not totally random. I did want to do something a little bit more different just to show you, remind you how it works as we go through. And so it should be fine. So we're gonna start from the positive side and move to the negative side. And so that's going to be a minus 6 as I cross through here. And then I'm going to go through the resistor. So that's minus 0.05 I2. That's because I'm going through in the direction that I identified my current. Continue around. I'm going to go through the 36. This is the minus to the plus. So that's going to be a plus 36 there. And then I'm going to go through this small resistor. So that would be minus 0.2 times I2. And now at this point I'm going to go through this one, but notice I did say current 1 was moving to the right here. And so when I go through that resistor, if the current really is going to the right, I shouldn't be losing potential as I go from the right to the left. I should actually gain the potential there. And so we want to go plus R2, which was 40 times I1. The same thing is going to happen when I cross this resistor right here, is that would be a plus 0.5 I1. And again, that's because I said the current was moving to the right and I'm moving to the left. If the current is moving from the right, this should be the high side, this should be the low side. This should be the high side, this should be the low side. So I'm going from the low side to the high side, so the potential should be increasing as I go from piece to piece. Again, we could be wrong with the current and it'll show up later anyway. Now I'm going to go through the 48 here, which of course that's going to be a minus 48 because I'm going from the positive to the negative. And then I'm going to go through this last resistor, and it is in the direction that's counterclockwise of the I2. So I'm going to go minus 78 I2. And that gets me back to the J where I started. So that's going to be equal to 0. All right. All right. And so again, I just simplified. I added the constants. I combined the I2 terms, and I combined the I1 terms, which gave me this right down here. And so now I've got 3 equations. Now I'm going to rewrite them. When I rewrite them, though, I'm going to rewrite them in what we would consider to kind of be our standard form, which is ax plus by plus cz equals d. And so any constants need to be over on the right-hand side, and then our variables are all going to be on the left-hand side. And so I'm going to have my first equation is going to be I1 plus I2 minus I3 equals 0. The second one, I'm going to move the 6 over to the other side, or I could move the I2 and I3 if I want those to be positive. In fact, I think I'll do that. I'll make it 78.25 I2 plus 25.1 I3, and that equals 6. And so I added these two, moved them over to the other side. Notice I did put them in the right column. I put the I2s together, I put the I3s together. That'll make it a little bit easier to put it in the equation later, the calculator later. And then of course I'm going to use this guy right here. And again, I'll move the things around. In this case, it's not too important. I'm going to go ahead and put the 40.5 I1 first, then I'll have a minus 78.25 I2, and then I'll move the 18 over to the other side, so equals 18. So notice again, I lined up the I1s, the I2s, and now this is ready to input straight into our calculator, all right? Now, if you're doing it on a Casio, that's what I'm going to talk you through right now. Unfortunately, I don't have a video easily. I could do it, but it would take me an extra half hour to put the video together. I'd rather just get it out for you. So I'll talk you through. You're going to push menu, which is up at the top under the F buttons, under the F4. And then in the menu, you're going to go down to where it says equation. Okay, that's the letter A. You can see the 1, 2, 3, 4, 5, 6, 7, 8, 9. This is letter A, equation. And when you push enter or execute, EXE, then it should say choose the type. We want simultaneous equations, so I'm going to choose F1 there. And when I push F1, it now says simultaneous data exists in memory. I'm not going to worry about that. How many unknowns? Well, there's 3 unknowns, so we're going to choose 3 unknowns. So to choose 3 unknowns, that's right above the F2 button. So I'm going to push the F2 button, and you'll notice now it just kind of gives me this matrix. So row 1 is my first equation. That's the I1, I2 minus I3 equals 0. So I'm going to put in a 1 for the I1 because I got 1 I1. Okay, and then I'm going to type in a 1 for the I2, and then the I3 is a negative 1. So I'm going to type in negative 1, and that's equal to 0. So I'm going to leave a 0 over there. Okay, and then I'm going to go down to the next row. And so I'm going to type in, this one doesn't have an I1, so I'm going to put in a 0 for the I1, and then I'm going to type in a 78.25 for the I2, that's positive, and then I'm going to type in a 25.1 for the I3, and then I'm going to type in a 6, because that's the constant over there on the right side. And then I'm going to go ahead and do the same thing for my last equation there. That's 40.5 for the I1. It's going to be a negative 78.25 for the I2. It's going to be a 0 for the I3 because there's no I3 in that last equation. And then an 18 in that last one right there. So type in the 18. And once I do that, sometimes if you push execute or enter, it just does it for you. It solves it for you. If not, you can push the F1, which actually does the solve. If you make a mistake and you get the answer page and make a mistake, you can push F1 again, which is repeat. And that will leave the data that you had before, and you can go back and change it or adjust it without having to redo the whole process. Okay, and again, you can push enter or execute, or you can push the F1 to solve. And when I do this, I got the X, which is I1. That's what I put in the first row. I got I1 equals 0.379 amps. I got that I2 is negative 0.033 amps, and that's fine. That just means I chose the wrong direction for current 2. It means that current 2, instead of going counterclockwise, is actually going clockwise, and that's fine. And then I3, I got 0.345 amps. All right, and there is a little bit of discrepancy because of the rounding there. That's fine. more or less when I add I1 and I2 together, I do basically get I3 there, which is what our first equation was. You'll notice it works in any of the equations. Obviously, that's the whole point of simultaneous equations, but there's your answer to the Kirchhoff's law problem. All right, let me know if you have any other questions. Try it with a different loop. Try it with a loop other than, you could use the top loop there, right, with the top half of the thing instead of the bottom half. Give it a try, and hopefully that was helpful for you.